Well, thank you so much for joining us here this afternoon. I think it'll be interesting for us to both share with you some of our perspectives on how we think about energy in the context of the greater range of sustainability challenges facing us, and then to dig deeper into the methods and tools and approaches that we have for doing so. Ian Monroe will share with me the talk. I will start with a sort of a general overview, kind of run through a range of tools and approaches that we use. And then Ian, who has real experience in this, will dig more deeply into a couple of the methods and approaches that we think are very important as we think about energy choices in the future. Ian, by the way, and I teach a course every year on very much these topics. So we'll start with a little bit of a perspective on how energy and our choices about energy are connected with the life support systems of the planet. Obviously, we know climate, but many of the others, and with how they interact with human needs. And then we'll, as I said, focus more deeply in some different kinds of tools and approaches for understanding our choices and what their impacts are. So, since I'm using the word sustainability there, let me give you my definition. Of course, many of you know that in the corporate world, we talk about the triple bottom line, or the 3 E's, or the three-legged stool for making decisions that make sense economically, environmentally, and socially. That's a great definition. The one that I use and that we use here at Stanford is one that we wrote as part of the National Academy of Sciences Board on Sustainable Development, and it's simply a statement of a goal. The goal of meeting the needs of people today and in the future, and by that I mean our needs for food, energy, water, shelter, employment, education, and so on, while at the same time sustaining the life support systems of the planet. And by that we mean our climate system, yes, but also the atmosphere and water systems, and the species and ecosystems on land and in the oceans that provide so many of the things that we need today. We get a lot of things from ecosystems that we don't even realize we're getting, but that will also be critical for our children and grandchildren and great-grandchildren in future decades. So a very simple statement. It's a huge challenge, and I know after sitting through this morning, you probably don't need me to remind us of how big a challenge that is. But on the social side, the meeting the needs of people side, it is true that some things have improved. Lifespans have increased, infant mortality rates are in decline just about everywhere around the world. More people have access to education and health care and clean water than ever before. And yet there are 1 billion adults who can't read, mostly women. There are billions of people who don't have access to clean water or to sanitation. Almost 1 billion people go to bed hungry a lot of the time, or don't have access to modern forms of energy. And that's today. The human population is still growing. We're likely to grow to 9.5 billion by the middle of this century when we level off for the first time ever. And of course, that population is continuing to consume. So huge challenges in terms of how do we meet the needs of people. There are also huge challenges on the other side, on the life support systems side. Again, we've improved some things in some places. We've learned how to deal with air pollution and water pollution, especially at local and regional scales, but we still have huge problems coming ahead. Region-wide tides of smog. We're changing the climate, obviously. We're acidifying the oceans. We're driving the loss of biodiversity at rates that are 100 to 1,000 times the background rates. We're running into all kinds of water and resource limitations. So got big challenges on that side. I think part of the problem for us has been that in the past, most of our attempts to meet the needs of people have inadvertently had negative consequences on the life support systems. We don't do this on purpose. It's just inadvertent part of our actions, our activities. So our challenge is to switch that relationship, and that's, of course, what GCEP is all about, and that's what many of us working here together are about. So if we think about meeting the needs of people for energy, of course, that's the key ingredient to just about everything we do. It's connected to so many other things that we need. We think about it, of course, in terms of industry and transportation systems and everything, but think about food. Think about the energy that goes into food production. We use fossil fuel energy, usually natural gas, sometimes coal, to produce nitrogen fertilizers that are essential, an essential ingredient to our ability to keep food production at pace with human population growth. We use energy to pump water that goes into irrigation of agricultural systems, as well as comes into our industries and homes. And the list goes on and on. It's a key ingredient. And so automatically you can see this link between how we use energy and how well we can meet all of those other needs that people have. This is an old graph that you all know very well. Obviously, because of those critical needs, energy demand's increasing. We're way off the scale at this point, and it's mostly fossil fuels that have been providing the energy resources. So what's the problem with that? Again, you all know that it's having unintended consequences. It's a major source of pollution of water and soil and oceans and land systems, but also greenhouse gases. Our change in greenhouse gases, changing the climate with impacts that are, interesting and important in their own right. But the reason I care about them is that they're affecting our ability to meet the needs of people for water, food, et cetera, et cetera. So what we have is this connecting of all of these dots here. We've got a very linked system. And this relationship between energy use and the other things people need is a real driver, at least for me, in terms of worrying about our energy future. So in the future, our job is to figure out how to meet those needs for energy without having those negative consequences. We need to make that relationship look like that. So we don't know how to do this. Many of you are engaged in trying to figure out how to do this. I would say we're in the midst of a transition. We've started down this road. We're trying lots of different things. We've got lots of experiments going on around the world, but we're not there yet. And I like to think, what is it going to take to move this transition to sustainability or to sustainable energy use or sustainability more broadly? What's it going to take to move it faster? And there's a long list of things, and I'd say that the top three here are things that we at Stanford and many of our colleague universities and research institutes around the world are working really, really hard on. We're trying to create those new technologies, new knowledge. We're trying to make sure that it gets into the hands of decision makers through, in part, projects like GCEP. And we're trying to make sure that we have an educated set of leaders coming along. Lots of other things that are just as important here. But we're going to have to do all of these things to move this forward. What I want to do, though, and what Ian and I are going to do, is just focus on this very first one. Just talk about the tools and approaches that we have to move energy along to a more sustainable path. And of course, when I say that, we automatically think about technology development, right? And that's what a lot of us do at Stanford. We're involved in the new technologies across the board that could lead to clean and cheaper sources of energy. But what we sometimes forget to do is think about not just the technologies, but how those technologies interact with other things we care about. So how do we decide, how do we make choices among those different types of energy in ways that don't have unintended consequences for the rest of the planet, for the life support systems of the planet? Obviously, we also need to worry about implementation barriers. We need to worry about trade and security issues, et cetera. But what we're going to focus on is those unintended consequences. How do we make choices that don't have unintended consequences, but rather have co-benefits that help more than one thing at a time? So our question is, what tools and approaches do we have? How good are they? And what else needs to be done on this front? So we actually have a long list of tools. It's kind of fun. I was the lead author for a National Academy of Sciences report called America's Climate Choices. And John Wyant and I and others did a report on advancing the science of climate change. And one of the things that we concluded is we have to get the scientific community more tightly linked with the energy technology community. so that we are making good choices about energy under different conditions in different places. And we asked the question in that group, what's out there? And you can see there's a long list of different tools that help us make good choices. Some of these are not developed at all, and we'll give you some of those examples in this talk. But some of them are really being pushed forward in their development and use for the issue. Probably the most well-developed of this suite of tools are called life cycle assessments. I'm sure the engineers in the room all know a whole lot about this. LCAs have been very, very critical as some sorts of alternative energy resources have grown. Biofuels are a great example, and we're going to use biofuels as part of our examples in this talk. When biofuels first came on the scene, corn ethanol, for example, 15 years or 10 years ago, there was an assumption almost that this is really going to be good for energy production, and it's really going to be good for reducing greenhouse gas emissions. And as LCAs came along, as the assessments started coming forward, it became very clear that it's not clear, that there's some winners and there's some losers. So let me show you a little bit about how this works, and then Ian's going to kind of do a deeper dive as part of this workshop into this kind of assessment. So, you start at the very beginning of the sort of cradle of production of, in this case, let's say, this particular set of biofuels, ethanol. And you have to think about how do we produce the crops the feedstocks that we're going to use to produce ethanol. Well, we do it in agricultural systems very often, and of course we have to fertilize them, right? We have to add a lot of fertilizer. As I said before, fertilizer is produced through an industrial process that basically uses fossil fuel energy to fix nitrogen from dinitrogen in the atmosphere, which is unavailable to plants, into available forms, nitrate or ammonium or urea, that plants can use. So there's a lot of use of energy in that process, a lot of CO2 emissions, and some other greenhouse gas emissions in the process. So then we're growing all of these are different options for biofuels. Okay, what do we have to worry about there? Well, in the agricultural practices themselves, there are emissions of greenhouse gases. Nitrous oxide is one. It's actually what I've spent a lot of my career on, how to reduce the emissions of nitrous oxide, but also carbon dioxide from agricultural systems. How do you figure out how much is being emitted? It's a huge amount of work over years and years to actually learn how much of these greenhouse gases are emitted under different types of agricultural practices. Now, 15 years later, we've accumulated a lot of information, but it took a long time to do that. So field-based work is important there. Likewise, at the plant production, where you're producing the ethanol, there are different types of approaches, different industrial methods that are used with different both energy input, output, and also with different emissions of greenhouse gases directly. And then you can go on all the way through to the refueling station, on out to the kinds of cars that use the ethanol fuel. And the bottom line for all of this is that these LCAs show us very clearly that all of this matters. You actually have to worry about what kind of crop you're using, what kind of system you're farming, how your production process works, and obviously what kind of vehicles you drive in it. And there's no sort of easy answer to this. So that seems complicated, but it gets a lot more complicated. And again, Ian's going to go into this, but one of the things that is very clear, as I go back to this slide, one of the things that's very clear is that what you had on the land before you plant these crops really matters. If you have a forest and you cut it down to plant the crop, you're going to have a huge emission of carbon that simply cannot be balanced by the benefit of the fuels ever. Probably thousands of years it would take to break even in that sense. Whereas if you're doing the agriculture on an abandoned agricultural land, then that's easy. And Ian will show you a little bit of information on that. So that's a complication, but an even greater complication, and one that's very hard to actually model, has to do with the fact that if you take lands, agricultural lands, and convert them into lands for biofuels, you're taking away food production land, basically. That will do a couple of things. It'll probably drive the price of food up because you're removing food from the market, basically. And it will push people into new lands for agriculture. And so then you have to account for the consequences of that in terms of emissions of greenhouse gases. So there's a type of life cycle assessment called consequential assessment that basically tries to get at those things that are not the direct but the indirect effects. And again, Ian will talk a little bit about that, but it's really, really hard. And it's an item of a lot of debate in the assessment community. And it's actually important because we're using it in laws. Okay, so that was life cycle assessment, and we'll come back to it a little bit in a minute, but I wanted to say there's also other approaches that are being developed to try to get at this link between our energy choices and what it means for greenhouse gases and thus climate. And one of the really important global perspectives on this are the integrated assessment models. And John Wyant is a world expert on that, and so I'm glad he's here. He can be engaged in the discussion around it. But basically what the integrated assessment models do are they take scenarios about population growth, about technology development, about economy, link it with energy systems, and then they end up linking with greenhouse gases, emissions, and climate models. But now we're talking at the global scale. And these have been very, very important in our scenarios of climate change in the future. These integrated assessment models have been the link to choices on the ground. I'm going to come back to that, but there's a lot of different models that have been developed to try to do that. And that's an important tool for the global community to think about our energy futures. But both of these examples that I gave you, the LCAs and the integrated assessment models that I just showed, are focusing pretty much strictly on net energy production and greenhouse gases, and thus climate. But what if you care about other things? What if I care more about fresh water? And in parts of the world, like where we live, you really care about water resources. Or what if I care more about food? So what kinds of tools and approaches do we have for these other sustainability issues? And again, they're being developed. The tools are being developed. In the case of the freshwater, there's a lot of work that's trying to embed the life cycle assessment for fresh water in the overall questions about energy choices. But you can see why. Of course, again, using our biofuels example, lots of water goes into agricultural production. And there's also a lot of pollution that comes out of agricultural production, depending on how you do it. And obviously, in the industrial processing, again, large demands for water, consumption of water in the products, and so forth. So if you want to ask the question, how important is, or how critical is this choice we're making, biofuels, solar, wind, or whatever else, for water in this system, in this particular place, we need to have an assessment like this. And again, Ian will show you an example of one that's being done. Food is an area that I work a lot into, and I'm, pretty critical question. How do our choices about energy affect our ability to provide food? Biofuels, of course, are the poster child in that one, and it's pretty clear that you would, just based on very simple economic theory, you would expect that that more demand for cropland for biofuels will cause an increase in food prices. And but there's tons of equilibrium, general equilibrium models, economic models, that play out through all the different scenarios and try to figure out just how much. There's agreement that, in fact, this is what happens, but there's disagreement about exactly how much these changes in food prices are going to affect the well-being of people. So what's missing right now in this question of food versus fuel is the integration of the general equilibrium models with social models, with models that speak to who wins and who loses if food prices go up. Okay, now there are a couple approaches that try to integrate across these. You can go through these one by one, and there's models and approaches that try to make direct connections. But there's also some neat things that are being developed to integrate across them. And one that Ian first showed me that I really think is kind of interesting is the use of indicator systems to help you with your assessment of the pros and cons of the choices you're making. So there's one group of Swiss that carried out a really nice analysis in which they used several different indicators to ask the question about different biofuel technologies and the costs and benefits of them. So what we're seeing here is, this is greenhouse warming potential. So this is just the greenhouse gas emissions from these are all different biofuels technologies. This index right here, indicator, is a Swiss indicator that is really based on the relationship between environmental impacts relative to legal limits or to standards. So that's a special little indicator that they've developed. This eco-indicator here is a European Union indicator system that tries to get a handle around human health and ecosystem health impacts of different choices. And if you want to know a lot more about how these indicators were put together, you can ask Ian. Yeah. But the bottom line of this is quite interesting. So here across the bottom, what you can't see are the fossil fuels, natural gas and various low and high sulfur sources. And you can see they've got pretty high greenhouse warming potentials. And if you look just at the greenhouse part, the greenhouse gas comparison, there's a handful of them that are actually worse than the fossil fuels. Corn ethanol from the US is one of them, by the way, according to this chart. But they're not helpful in terms of reducing greenhouse gases. And you see those same ones don't show up very well in these other indices either. So those are definitely out. And as you go up higher, you have a whole suite of different kinds of biofuel systems that are actually better than fossil fuels in terms of emitting greenhouse gases. But many of them are not better than fossil fuels in terms of their consequences for environmental impacts, or for human health, or for ecosystem health. So it's only when you get to the very top that you begin to see these indicators telling us that those biofuel sources are ones we should be focusing on. And you can't see what they are, but I'll tell you what they are. Basically, the conclusion of this study is organic waste materials are really, manure and methane from manure and recycled oil and things like that are the smart choices for biofuels. And right now, nothing else is, according to this analysis. But those kinds of indicator systems are actually kind of useful, I think, for getting a broader sense of our choices and the impacts of the choices. Okay, now I want to go back to integrated assessment models, because here's another way that we're moving towards an integrated view of the consequence of different types of energy choices. As I showed you this before, there's integrated assessment models. They're connected with climate models. And they really haven't been connected very much with the impacts models that are impacts on the planet's ecosystems and water systems and so forth. Today, and John can tell us a lot more about this, there's a big push to make these different types of models integrated so that one can run scenarios about the economy and energy and climate, but also learn something about impact on human health, on ecosystem quality, and so forth. So we're moving in that direction. This is a global scale, but at regional scales, I won't bore you with details on it, but there's emerging models. Again, they're trying to link regional scale simulations of these different processes together in order to provide us some insight, for example, on issues of forest biodiversity and the impact of biofuels on them. So we're moving in that direction, and they're not there yet. Okay, so another very general type of tool that is very useful in trying to make choices that don't have negative impacts is multi-criteria analysis. This is basically spatial analysis of land or water systems to try to understand where different energy choices make sense. So, and I think it's been used now for biofuels, solar, wind, dams, probably could be used for a lot of other kinds of things. And Ian's going to give you some more specific examples of this because he's worked in it. But I want to give you just enough to get a sense for how this works. So say you're trying to identify the right places to develop wind or solar. One way you can go about it is to develop layers of information about land that could be used for these areas. So obviously a place to start is to say, where is the resource the best? You'd look at maps of wind or maps of solar input like this one, and you can begin to pick out areas where we ought to be focusing our attention at a pretty coarse scale. You can also get these maps for very fine scale. You might also want to look at protected areas and say, well, let's not even worry about the land that's protected for conservation already, the national and state parks and the reserves and things like that. Well, there's really good data on where they are located spatially, and that as an overlay on where the sun is or where the wind is helpful. You might want to identify areas that are already degraded. So, a lot of my colleagues are working in old oil fields as a great place to put solar or wind if everything else is right. Or, let me see, here's a map that shows some of them. You might go to a Superfund site, or old landfills would be great places to site alternative energy. And you can, again, develop maps of those kinds of land, of those land types. And you can do the same for land ownership and for transmission access. And this is actually what's being done right now in some places. And using that, you can identify, going in, the best sites for development. This is a list from the American Wind Energy Association. If they're talking about siting of alternative energy sites, they basically say, get that first one right first. Identify the places that don't have a lot of conflicts, that don't have a lot of unintended negative consequences on other things we care about. And then when you get that right, it's a lot easier to move through the system and get to where you want to get, which is siting that energy plant. Okay. So I think the multi-criteria analysis is really great, and it's very, very important and very useful. And Ian will talk more about it. But one of the things that bothers me about it is it just gives us a glimpse at today. It doesn't allow decision makers to have a sense of what future options might be for those land or water areas where you're siting these things. But to do that, there's a really different kind of modeling approach that's called ecosystem services assessment. Has very rarely been used in the context of siting energy right now, but it could be used, and I'm going to show you one example of how it could be used, the ecosystem services assessment. Now, before I do that, let me tell you what ecosystem services are, how we think of those. The bottom line is that we get lots and lots of things from the land and water and ocean systems of the planet. We get a lot of things we realize we get, like food crops and energy crops and seafood and so forth. We all know that. But we get a whole bunch of other services that we tend not to recognize, or we don't think about. We get services like, for example, a place to store carbon. Or we get watershed services, fresh water. We get flood control or sediment control, things like that. And then we get a whole bunch of other services that we just take for granted. Places that we go for recreation, places that we go for inspiration, that we value for that. We as humans value for that. And one of the big challenges has been, how do you get people to recognize all the things they value from that piece of land or that piece of ocean? And the ecosystem services models are helping us get our hands around what those values are. They're not necessarily putting dollar amounts on them, but they're at least helping us be explicit about the value. And there's a whole bunch of ecosystem services models now available. Some of them are incredibly simple. They're basically lookup tables, maybe questions about risk and opportunity, maybe a little bit of baseline information embedded in them. But some of them are much more sophisticated. They're process models, they're simulation models that they are linked with geographic information systems and linked with decision support systems, basically, so that decision makers can use the models to ask questions about their land. And one of those that's like that is one that was created here at Stanford. It's called the NatCap, or Natural Capital Project. Gretchen Daly, some of you may know, is a faculty member in the Department of Biology and the Woods Institute for the Environment. She's leading a big team. It's a partnership with the World Wildlife Fund and the Nature Conservancy and a couple of other universities. And they've created a model that's called the INVEST model that is being used and tested all over the world right now. But let me just give you one quick example of a test that was done, use of this that was done in Hawaii. In a very big piece of land, 26,000 acres of land on Oahu's North Shore, prime land, owned by Kamehameha Schools, just freed up from a long-term lease, and they were trying to decide what to do with it. They used the INVEST model and the process to explore different futures for it. So they basically developed a land use map of that piece of land that they owned, and then they worked with local stakeholders to run some scenarios. So what are the possible uses of this land in the future? One could be they could go full into biofuels. Biofuels is a big deal in Hawaii right now. Or they could turn it into subdivisions. On Oahu, that would probably not be a bad idea. Or they could do sustainable agriculture. Or they could deforest it, and there's a lot of other scenarios, but here's 4 to look at. Then once they had the scenarios, they ran the scenarios in their spatially explicit models to ask what would happen to a variety of ecosystem services that those people cared about. So one, let's say, is carbon storage. Say you want to use, if there's a carbon market, you want to be able to use your land to store carbon and get carbon credits for that. So the biofuels scenario does not do good for carbon storage. You can see the negative values over there for change in tons of carbon stored in the soil. That didn't work too well, but subdivision didn't work very well either, not quite as bad. But the sustainable agriculture and forestry scenario actually takes it positive. So there's this green is all positive storage of carbon. So they could use that approach if they decided, if there were a carbon market that they wanted to benefit from, but also if they wanted to get the benefits of agriculture and forestry. Anyway, to make a long story short, they basically did this for a whole bunch of different services for these different scenarios, and just sort of quantitatively and qualitatively indicated what direction the benefits go. And you can see that in biofuels case, a lot of things go down. Probably not a good choice for them. Agriculture and forestry, more things go up. And then when you add in other services like biodiversity values, recreation values, that becomes an even bigger winner. So I think in the end, Kamehameha Schools is the one who makes the decision. I think they chose this, actually. But the whole point here is this is information for a decision maker to decide whether this is the place to do your biofuels or not, to decide if this is a place for one choice among energy or water or something else and another. It's another one of the tools that's available. And it's just in its infancy, and I think would be very, very helpful in the future. Okay, so long list. I'm not going to go through any more. In fact, I want to turn it over to Ian at this point. But I do want to say, a lot of these are modeling, involve modeling. Some of them are assessments that include indicators. There's a lot of questions about all of this. And one of the things that we all agree on, I think, is that models are only as good as their assumptions and as good as the data that go into them. And I don't know how many of you have read this book called The Fires. It's a fascinating story about why New York City burned down a few decades ago. And it's really about a problem that occurs when a bunch of folks like us start running a whole bunch of models without actually talking to the stakeholders and making sure that our assumptions are right and that the data are good. So without engagement of decision makers, we're not likely to get a right answer no matter how many wonderful tools and approaches we develop in our community to use in making decisions about energy futures. So with that, I will, I guess what we can do is see if anybody has any questions or comments now. Then Ian will do a deeper dive, and then we'll have at least a half an hour for conversation. We can put John Wyant on the spot then about integrated assessment models too. Yes.
So a question to gain your insights, perhaps put you on the spot for some thinking. Across the United States, what percentage of the population, adults, do you think understands ecosystem services?
Yeah, it's very few. No, it's actually a really interesting question because I've just been talking. I lead a science leadership and communications group, and it's very clear that ecosystem services is not a term that is understood. But so, do people understand ecosystem services as a term? No. Do they understand that they get things from their surrounding lands and water systems? Partially. But it's very variable, and it's not a complete picture. So part of the challenge here is just to find ways of making sure that people realize that by degrading those places, you're going to lose something that is going to matter to you. And unfortunately, the way we usually find that out is after it's too late. So trying to get ahead of the game is what Gretchen Daly's all about. But you're right, the terminology is not something that most people get. Yes?
Well, just to comment to this question and this question. If you're with the government agencies, such as the Department of Transportation, dealing with the environmentalists, there you really have the definition for their existing services.
Right.
Again, what previous slide, can you explain this certification system of the...
Yeah. Ian, do you want to talk about certification systems? There's a bunch, but
I'll dig into it. I'm going to talk specifically about the roundtable on sustainable biofuels and the certification system they've created. So I'll talk about it in a few minutes.
yeah. And these are tools that are used for a lot of different resources. You know, for fisheries, for example, for seafood, or for forestry certification. And the idea is that if you can prove that you have been managing in a sustainable way for the long-term welfare of the resource as well as the short-term, you get some advantage. And some of the major corporations have bought into only purchasing certified lumber, for example, or certified seafood. It's a huge, really important and non-legislative change that I think has got a lot of value. But we'll see from Ian's work on how it actually plays out for biofuels. Oh boy, lots of questions. Yes, sir.
How do you deal with the political aspect of all this? You show that ethanol is not a good deal, okay? But once the people in Iowa think that they can make a lot of money, they don't like to hear that, and it's going to take a long time to convince them that it's a bad thing. And as a matter of fact, it may not be possible. Yeah.
No, you're so right. I just tear my hair out over this. Part of the problem is most of the people in the government, in the DOE, and even in the USDA, would say, that was just our first try. Don't worry about it because we're moving on to new and better kinds of biofuels, switchgrass, and there's lots of technology coming down the road that might really be good for biofuels. I hope they're going to be good for biofuels. But your point is right on. The fact is we've converted huge areas of land to corn ethanol. There are manufacturing plants all over the Midwest. And it's now a part of the economy there. And farmers are getting double subsidized to grow corn. So politically, it's a very, very challenging thing to change. So this is why these tools are so important, because if we use these tools before we go down that road, we don't set up this insurmountable barrier. And honestly, I think, I don't know the inside scoop on all of this, but I think there was too little conversation going on between the energy folks and the agriculture folks and the environmental folks when that whole thing was put together, a decade or more ago. And now I would love to see that kind of conversation going on in the government.
They did suggest when the drought was hurting the farmers that they should change the amount of ethanol regulations that have to go into the
yes, yeah,
so that there would be more corn for food.
Right.
I don't think they succeeded.
No, I don't think so either. And meanwhile, the rest of the world is either paying a huge amount for food or they're converting a whole lot of land into corn or soy. So now we worry about what's going on in Brazil or what's going on in China in terms of, it's a connected, the food, commodity world is a globally connected one, as is the energy one. And so there are great people at Stanford who work on that. Roz Naylor's Food Security and Environment Group is, one of the great experts on that topic. So she can give you the deep dive into that. Yes.
How are we going to pay attention to the need for education and public outreach? A lot of times that's not done.
Yes, I know. So the question was, what about education and public outreach on these kinds of things? Well, we do believe that we're doing a good job on the education part, and I can tell you the demand for this kind of systems thinking is huge at Stanford. In my school, we have the interdisciplinary undergraduate and interdisciplinary graduate programs in resources and environment, and they're just growing in leaps and bounds. There's so much demand. So students are moving in the right direction on this, and I think this is true across the university. That's why I can stand here and be optimistic about it. But the bigger issue is, how do we communicate in a political environment that it's almost no matter what we do is going to be a challenging political environment to communicate in? How do we get that word out? How do we express some of this information and the values? And we don't do terribly well on. We created, though, at Stanford, the Woods Institute for the Environment and the Precourt Institute for Energy. Probably all of you know about the Precourt Institute, to help us do that, to be more of a linker between what we learn and know in our little academic world and what is being communicated to decision makers of all sorts. So it's a big change. I think it's happening here and in many other universities, recognizing that our job is to link that knowledge with decision-making action. Not to tell them what to do, but to provide them better information to make better choices. And that's what this is about. But we're moving in that direction again, but we're not there. Yes?
There a question, a broader question. There a question, do these methods or models support multi or mixed use?
Yeah.
Versus just single use?
Yeah, it's a good question.
And the broader question is, do any of them support the trade-offs between social indicators, social factors, and environmental?
Yeah. Well, I think, and Ian can speak to this too, but I think one of the big challenges for these kinds of tools in the future is to let people have a better understanding of trade-offs and co-benefits. Right now we can see impacts pretty well, but we don't have all the tools to really understand the trade-offs that we're making socially and environmentally. So it's I would say that's a recognized need, but it's not really great. And Ian can speak.
Yeah, it's starting to get there. I'll talk about it a little bit more, but the social side is particularly difficult to quantify. So you can quantify predicted human health impacts, for example, with the WHO's disease-adjusted life years, and a lot of other social impacts in terms of, say, labor rights and healthcare access and things like that are more difficult to put into a unified quantitative framework that then you can feed into one of these life cycle impact assessment models that are out there. So there are a lot of researchers working towards doing that, but it's definitely an iterative process that hopefully is improving.
One of my colleagues and I are developing a graduate course in sustainability and engineering, and we're actually looking at how do you do the trade-offs.
Yeah.
And we found that you have to look at a particular community.
Oh, yes.
Ecosystem, and what's important to one community is not necessarily important to another community, whether it's jobs or whatever.
Right. Well, Ian, your example includes some of the stakeholder engagement in the decision-making process. I was going to say one thing about these tools, though, is that they become an object, in a sense, or I can't think of the right word. They become a venue in which to engage decision makers, and these are social decisions. There's never going to be one right answer. It does come down to stakeholder engagement in social decision making. And so I think that all of the work that we're doing on, that some of the folks in engineering are doing on as well, sort of how to better engage stakeholders and how to build decision support systems that help their engagement is an important part of this too. Yes?
Oh, you know what this reminds me? Prior to NEPA 1969, when we were going to build a dam.
Yeah.
Boy, we didn't have any talk to God. After NEPA 1969, after CEQA 1970, then it became policy guidelines.
Yeah.
Right now, when I'm with the Department of Transportation, I have very rigid policy guidelines, what to do, what not to do. So that is where it's coming, and your knowledge and all this is coming to framework that eventually going to be into another NEPA type,
Another regulatory approach.
use those policy guidelines, and then do your design, do your work in that framework.
Yeah. Well, I think, I mean, obviously that's an important part of in the future, but I think my sense is that these certification systems, the indicators, all these things actually can work together for even better outcomes, but ultimately regulation helps. Okay, one more question and then we will end this and turn it over to Ian.
I really like your framing of sustainability. I understand it's Stanford's framing, but this idea that our life support systems are degraded and therefore the social needs aren't being met. It goes to the fundamental self-interest of most of us humans.
Yep.
But just reading through some of these lists on how our life support systems are degraded, you know, the one that's really struck me at this moment was that biodiversity loss is 100 times faster than ever before. And that, if you translate it to English, plain English, means that species are disappearing from the planet.
Yeah.
And so part of this is like a communications thing. You know, it took me a while to translate that kind of academic ease into real terms.
Yeah.
So, I mean, if you stop to think about the fact that the numbers, but possibly thousands of species are going extinct, gone from the face of the earth, every couple of years, that's a message that could really resonate with even the most self-interested.
It is a message that resonates with a lot of communities, but not all of them. But for the communities that it doesn't resonate with, think about this. Most of our drugs came from those species that were out there in the rainforest that we never even knew about and are disappearing before we even know their name. You know, so sustainability is a very anthropocentric concept. It's about us, you know. And so I'm in a school of earth sciences. Some of my colleagues are studying the planet 4 billion years ago, and they're saying, the planet's going to be fine, you know, no matter, don't worry about it. And I'm going, yeah, but it's us, you know, we're worrying about us, but not just us. We're worrying about our grandchildren. And so, yes, thank you for worrying about the species with whom we share the planet, and I do too, and a lot of us do. But somehow it's reaching all of those audiences. Yeah, thank you. Okay, Ian.